Welcome to Senior High School Math Series. In this presentation, let us discuss z-test for a mean under statistics and probability. Before we continue, let us recall and summarize the steps in hypothesis testing. A video lesson on hypothesis testing was uploaded prior to this video. If you haven't seen it, the link is on the description of this video. Number 1, state the hypothesis and identify the claim. Next step is to find the critical value from the appropriate table. For z-test, we use the standard normal distribution table. A copy of the z-distribution table may also be downloaded from the link given on the description of this video. Third step is to compute the test value. Next is to make the decision to reject or not to reject the null hypothesis. Step number 4 is based on the results of step number 2 and 3. Last step is to summarize the result. In summarizing the result, we state the conclusion based on the steps number 1 and number 4. This time, let us have some definitions. The z-test is a statistical test for the mean of a population. In this video lesson, we are concerned with z-test for a mean. The z-test can be used when the sample n is greater than or equal to 30 or when the population is normally distributed. Also, we use the z-test when the population standard deviation is known. Many hypotheses are tested using a statistical test based on the following general formula. Test value is equal to the observed value minus the expected value all over the standard error. The observed value is the statistic, such as the mean, that is computed from the sample data. The expected value is the parameter, such as the mean of the population, that you would expect to obtain if the null hypothesis were true. In other words, the hypothesized value. The denominator is the standard error of the statistic being tested, in this case, the standard error of the mean. The formula for z-test value is given by z is equal to x bar minus mu all over lowercase sigma divided by the square root of n. The z-test is our test value. X bar is the statistic or the sample mean. And based on the general formula from the previous slide, this is our observed value. Mu is the parameter, or this is the population mean, and based from the general formula, this is our expected value. Lowercase sigma is the population standard deviation, and n is the sample size. Based on the general formula, lowercase sigma over the square root of n is our standard error. Let us have an example. Number 1. The accountant's base salaries. A researcher reports through a social media site recently that the average base salary of accountants in the country is 28,379 pesos per month. A sample of 30 accountants has a mean salary of 30,260 pesos. At alpha equals 0.05, test the claim that accountants earn more than 28,379 pesos per month. The standard deviation of the population is 4,730. For step 1, we state the hypothesis and identify the claim. For the null hypothesis, we say there is no difference in the base salaries of accountants. In symbol, we write H sub 0, mu is equal to 28,379 pesos. For the alternative hypothesis, we say there is difference in the base salaries of accountants. And in symbol H sub 1, mu is greater than 28,379 pesos. For the alternative hypothesis, we write mu is greater than, since in the problem it states that test the claim that accountants earn more than 28,379 pesos per month. Hence, the claim in this hypothesis test is the alternative hypothesis, and this is a right-tailed test. For step 2, we find the critical value. Since alpha, or the significance level, is at 0.05, the test is a right-tailed test. Hence, in the normal curve, the z critical value is to the right of the mean. The area to the right of the z critical is our alpha, that is 0.05, and to the left, that will be 1 minus 0.05. So the area to the left of the z critical value is 0.9500. In solving for the z critical, or in identifying the critical value for z, we use the standard normal distribution table. Since the area to the left of the critical value for z is 0.9500, we look for that area on the table, and the closest is 0.9505. Hence, on the first column, we see 1.6, and on the first row, that is 0.05. Therefore, our z critical is 1.65. In some texts, authors may use interpolation for the critical value. Since 0.9500 is between 0.9495 and 0.9505, they use z is equal to 1.645. However, in our previous discussion, we round the z value to 2 decimal places, hence it's positive 1.65. So the critical value for z is 1.65. For step 3, we compute the test value using the formula for ztest value. From the given information, the mean is 28,379, or that is the population mean. The sample mean is 30,260. The population standard deviation is 4,730. And the sample size for this study is 30. Substituting this information to the formula, we have z is equal to 30,260 minus 28,379 all over 4,730 divided by the square root of 30. Using our scientific calculator, we can simply press these values so that we can solve for z. 30,260 minus 28,379. In the denominator, we get another fraction, and then press 4,730 over the square root of 30. The answer is 2.17815, and so on. Hence, we round this off to 2.18. Therefore, the test value for z is 2.18. Step number 4, we make the decision. From step number 2, we identify the critical value as 1.65, and the area to the right of that 1.65 is 0.05. To the left of the z critical value is 0.9500. To the right of the critical value is our critical region, and to the left, that is our non-critical region. The test value of 2.18 is greater than the critical value of 1.65. Since it falls on the critical region, the decision is to reject the null hypothesis. For the last step, we summarize the result. Recall that in step 1, the claim is the alternative hypothesis, that is, there is difference in the base salaries of accountants. And in step number 4, recall that we rejected the null hypothesis. Therefore, our conclusion, there is enough evidence to support the claim that accountants earn more than 28,379 pesos per month as base salary. In the outcomes of a hypothesis testing situation for drawing the conclusion, there are two cases. Case 1 is when the null hypothesis is the claim. If the null hypothesis is rejected, then the conclusion or the outcome is that there is enough evidence to reject the claim, and we write the sentence based on the given problem. When the null hypothesis is not rejected, that is, do not reject H sub 0, the conclusion is there is not enough evidence to reject the claim. For case 2, when the alternative hypothesis is the claim. In this case, when the null hypothesis is rejected, the conclusion would be there is enough evidence to support the claim. And when the null hypothesis is not rejected, the conclusion would be there is not enough evidence to support the claim. In example number 1, our claim is the alternative hypothesis, and the null hypothesis is rejected. Therefore, the conclusion is that there is enough evidence to support the claim. Let us have another example. Ages of Philippine congressmen. The mean age of congressmen in the 18th Congress was 52 years. A random sample of 35 congressmen from various legislative districts in Luzon had an average age of 50.6 years. And suppose that the population standard deviation is 6.5 years. At alpha equal to 0.05, is there sufficient evidence that congressmen from Luzon are on average younger than the congressmen in the 18th Congress? Let us have step 1. In this example, in writing the hypothesis, we will just use the symbols. So for our null hypothesis, mu is equal to 52 years. And for the alternative hypothesis, mu is less than 52 years. From the problem, it says, is there sufficient evidence that congressmen from Luzon are on average younger than the congressmen in the 18th Congress? So we use the symbol less than. And this is our claim. For step 2, find the critical value. From example number 1, in a right-tailed test, the critical value for alpha 0.05 is positive 1.65. In this case, at alpha 0.05 and we are in a left-tailed test, then the critical z value is negative 1.65, and this is obtained using the z distribution table. It is important to be able to use the standard normal distribution table in finding the critical value for z at a given level of significance, or alpha. However, since most tests are at alpha 0.01, 0.05, and 0.1, we can prepare a table of values so that it will be easier to identify the appropriate critical value for z. At alpha 0.01, in a left-tailed test, we use negative 2.33. In a right-tailed test, we use 2.33. And in a two-tailed test, that will be positive negative 2.58. At alpha 0.05, this is for example number 1 and 2, For example number 2, we are in a left tail test, so we use negative 1.65. In example number 1, we found that for a right tail test, it's 1.65. Now, in a two-tailed test for alpha 0.05, we use positive negative 1.96. At alpha 0.1, a left-tailed test will use negative 1.28 as a critical value for Z, positive 1.28 for a right-tailed test, and positive negative 1.65 for a two-tailed test. Step 3, we compute the test value. From the given information, mu is equal to 52 years. The sample mean is 50.6 years. The population standard deviation is supposed to be 6.5 years. And the sample is 35 congressmen from Luzon. Substituting these values to our formula, then z-test value will be equal to 50.6 minus 52 divided by the standard error given by 6.5 over the square root of 35. Using our scientific calculator, we will get z is equal to negative 1.27. So the test value for z in this example is negative 1.27. Step number 4, we are to make the decision. From step number 2, we have the critical value as negative 1.65. The area to the left of this critical value is 0.05, that is our alpha, and to the right is 0.9500. The critical region is that area to the left of the critical value, and the non-critical region is the area to the right of the critical value for z. The test value z is equal to negative 1.27 is greater than the critical value, so it falls on the non-critical region. Therefore, the decision is do not reject the null hypothesis. Step number 5, we summarize the result based on the claim, and step number 4, there is not sufficient evidence that congressmen from Luzon are on average younger than the congressmen in the 18th Congress. Let us have example number 3. Doctor of Education degree holders in the Philippines receive an average annual salary of 780,000 pesos according to payscale.com. The Dean of Graduate Studies at a large state university in the National Capital Region feels that the report from payscale.com is different from the actual average. He surveys 36 randomly selected Doctor of Education degree holders and finds that their average salary is 801,000 pesos. Suppose that the population standard deviation is 65,000 pesos, with alpha equal to 0.01. Is the Dean correct? Let us start with our null hypothesis, and that is mu equals 780,000 pesos. The alternative hypothesis, mu is not equal to 780,000 pesos. Remember, it says that the Dean of a Graduate Studies at a large university in NCR feels that the report from payscale.com is different from the actual average. So it says it's different from the actual average. Therefore, it is not particular whether it is lower or it is larger than the average. Hence, we use not equal to 780,000 pesos. And this is our claim, the alternative hypothesis. Next is the critical value. We have alpha 0.01 and the test is a two-tailed test. We can use the table that we did in example number 2 to find the critical value. At alpha 0.01 in a two-tailed test, the critical value for z is positive negative 2.58. Next step, we compute for the test value. From the given information, we have mu is equal to 780,000 pesos. X bar, or the sample mean, is 801,000 pesos. Population standard deviation is 65,000 pesos. And the sample size is 36. Substituting this information to our formula, we have Z is equal to 801,000 minus 780,000 all over 65,000 divided by square root of 36. Again, using our scientific calculator, we will get the test value for Z is equal to 1.94. In making the decision, based on step number 2, we have our critical values as negative 2.58 and positive 2.58. Hence, the two critical regions will be to the left and to the right of the mean, with area equal to 0.01 divided by 2, and each has 0.005 as the area, that is to the left and to the right of the mean. In between the critical value for Z, the area is 0.9900. The critical region is that area to the left, 0.005, and to the right of the mean, that is 0.005 also. The test value is 1.94, that is between the two critical values of positive or negative 2.58. Hence, it falls on the non-critical region, therefore the decision, do not reject the null hypothesis. To summarize the result, from the claim and from step number 4, we say there is not enough evidence to say that the dean is correct. For our next presentation, we will discuss t-test for a mean. That will be all. Thank you for watching. Please subscribe for more of math lessons.